Hello, today we're talking about rational numbers and irrational numbers. So these are just different names that we can classify numbers as, okay? And we also are going to go into a little more depth and start with the very broad term, like rational numbers, and see how numbers can be named more specifically, going to integers and then also whole numbers, okay? So let's start with the specific numbers. The most specific ones we have for this lesson, we're talking about whole numbers, okay? So these are all the positive numbers that are whole, okay? When you think of something that is whole, right, you talk about people. People are whole people, right? You can never have half a person, right? You can never have 3/4 of a person. So a whole number, it's positive and it is something in its entirety, right? So some examples of whole numbers are the numbers 2, the numbers 3, the number 102, okay? And then I put in some additional ones where, depending on what level you're doing this or you're practicing these skills, you might see the values represented in different ways that maybe aren't as obvious, right? The number 2, that's pretty obviously a whole number. But what about the square root of 4? Well, if you take the square root of 4, the square root of 4 is positive 2. So that number is a whole number, right? Now, it might look more confusing, but the square root of 4 is 2, and so it's a whole number. I also have there negative 2 divided by negative 2. Again, it looks more complicated, but ultimately, if you did that division problem, right, a negative divided by a negative is a positive, and 2 divided by 2 is 1. So negative 2 divided by negative 2 will be positive 1. So that makes it a whole number. We see 10 divided by 5, right? You see, hey, that's a fraction. That's not a whole number. Well, actually, it simplifies to the number 2. So it is a whole number. Okay? Now, whole numbers are also integers. Notice how the whole number box is in the integer box, right? All those numbers that are whole numbers, they're also integers. Okay? For integers, what this adds on is this adds on the negative versions of the whole numbers. Okay? So we see, for example, negative 7. Negative 14, okay? We have negative the square root of 9, right? Which, that would be, well, the square root of 9 is 3, and then since there's a negative sign there, that would make it negative 3, okay? So those are integers. Now, integers, those are within rational numbers. So all integers and all whole numbers are rational numbers, okay? And rational numbers, what that adds on is that adds in the decimals or the fractions. Right? So like 2.5, okay? That's not an integer, it's not a whole number, but it is a rational number, okay? Negative 7 over 4, 3 2/3, okay? Those are all rational numbers, okay? A good rule for rational numbers is if it can be written as a fraction, then it is a rational number, okay? Some other values that are included in here are called repeating decimals. So we have, for example, 0.6 repeating or 0.27 repeating. Those numbers are rational numbers, okay? 2.5, that's what we call a terminating decimal because 2.5, it ends. To terminate, it means to end. Now, the irrational numbers, the numbers that are included in there, there's some pi. Pi is an irrational number because if you wrote that out, it's going to be 3.14, and then the numbers will continue on forever, and they will not repeat. Okay, we have the square root of 8. Okay, so if you plug that into your calculator, what's the square root of 8? Well, it's 2.8284, and then continues on. Okay, we see another example with the decimal like 0.303003003. It's not repeating, okay? It has a different pattern. You might be able to notice that pattern and say, oh, well, it adds an extra 0 between the 3, but that doesn't make it a repeating decimal, right? It needs to be a consistent repetition. So that would be a non-terminating decimal, and so those are irrational numbers, okay? Now, you'll notice when you're working with rational numbers that repeating decimals, okay, those are rational numbers. And those, they do go on forever, but when they're repeating, they're considered rational numbers, okay? There are ways, we're not going into it in this lesson, but there are ways to write a repeating decimal as a fraction, okay? There are ways to do that. We're not covering it in this lesson, but it is possible. And remember, I said if you can write write a number as a fraction, it's rational. You cannot. The same is not true for non-terminating numbers like the ones in the irrational number section. So that is a brief rundown of rational numbers and irrational numbers. Good luck with your work today.